Hello everyone, my name is Sophie van Oosterwijck and today I will present to you the results of 3 studies examining the influence of physical activity on central pain modulation. Let's zoom in on the introduction first. The first measure of central pain modulation we examined is conditioned pain modulation. This is also known as pain inhibits pain. It is a paradigm in which we examine how well one painful stimulus inhibits the perception of a second painful stimulus which is applied to a remote site of the body. The second measure is a nociceptive deflection reflex. This is an involuntary spinal reflex which allows withdrawal of your limb from a painful stimulus. Experimental measures such as conditioned pain modulation and a nociceptive deflection reflex are susceptible to influence of non-modifiable and modifiable factors, such as physical activity. Based on a systematic review, there is limited evidence for an association between physical activity and conditioned pain modulation. However, previous research has mainly used questionnaires to assess physical activity levels. Therefore, this evidence needs to be substantiated with research using behavioral physical activity measures. Literature about the relation between physical activity and a nociceptive deflection reflex is less extensive and has not yet been systematically summarized. Therefore, these 3 studies expanded on previous literature and examined how physical activity influences endogenous pain modulation in healthy adults. The first study we carried out was a systematic review and meta-analysis examining the influence of physiological factors, including physical activity, on the nociceptive deflection reflex. Next, we performed 2 cross-sectional studies to examine the relation between physical activity and the nociceptive deflection reflex and between physical activity and conditioned pain modulation in healthy adults aged 18 to 65 years old. Physical activity during 7 consecutive days was measured using self-report, namely using the International Physical Activity Questionnaire in Dutch, and using behavioral measure of physical activity, namely an accelerometer watch which was worn around the wrist for 7 days. In the study examining the relationship with the nociceptive deflection reflex, the reflex was elicited by electrical stimulation of the sural nerve, which was delivered transcutaneously, and objectified using surface electromyography of the ipsilateral biceps femoris muscle. We assessed 2 outcomes, namely the reflex threshold, which is defined as the stimulus intensity at which the reflex occurs, and the reflex magnitude, which is the reflex activity of the biceps femoris muscle. In the study examining the relationship with conditioned pain modulation, we used the heterotopic noxious counterstimulation paradigm. The conditioning stimulus included the immersion of the non-dominant hand in a hot water bath of 45.5 degrees Celsius. The test stimulus includes the assessment of pressure pain thresholds using algeometry on the neck muscle, the middle finger and the calf muscle. The CPM effect was calculated as a change score before, during and after immersion of the hand in a hot water bath, as well as area under the curve calculations. Then we performed correlation analysis and hierarchical linear regression analysis because the latter allows to control for demographic and cardiovascular confounders. Let's have a look at the results. Our systematic review and meta-analysis on the influence of physiological factors on the nociceptive deflection reflex identified only 1 study examining the relationship with physical activity. This study found that highly active athletes have higher NfR thresholds compared to less active people. To expand our knowledge, we performed a cross-sectional study examining the relationship between physical activity and a nociceptive deflection reflex in 54 healthy adults. Based on the behavioral physical activity data, we found that higher amounts of step counts results in higher NfR thresholds, and that amount of step counts accounts for 35.2% of the variance in NfR threshold. Secondly, we found that higher amounts of sedentary activity results in lower NfR thresholds, and accounts for 35.8 to 0.9% of variance in NfR threshold. Based on self-report data, we found that more time spent on moderate intensity physical activity results in higher NfR thresholds and accounts for 23 to 37.1% of variance in NfR threshold. Our cross-sectional study to examine the relationship between physical activity and conditioned pain modulation included 105 healthy adults. We found no significant results using the behavioral physical activity data, But using the self-report measure, we found that more time spent on moderate intensity physical activity results in more efficient conditioned pain modulation and accounts for 3.5 to 4.2% of variance in conditioned pain modulation. Let's end with our conclusion. We found that a physically active lifestyle is beneficial for spinal nociception and endogenous pain modulation in healthy adults. This was evidenced by increasing amounts of step counts and more time spent on moderate physical activity, resulting in higher NFR thresholds and more efficient conditioned pain modulation. On the contrary, more time spent on sedentary activities was found to lower NFR thresholds. Based on previous research, we know that chronic pain populations have less efficient conditioned pain modulation and increased spinal nociception, evidenced by lowered NFR thresholds. Based on these results, we can now better understand the beneficial effects of exercise in these chronic pain patients. As walking and moderate intensity physical activity are achievable goals for chronic pain patients, these should be added to treatment programs to alleviate the pain complaints through indirectly improving spinal nociception and endogenous pain modulation. Thank you for your interest in our research. If you have any questions, do not hesitate to contact me through my email, which is listed below.